global development model we know is based on a principle of unlimited growth that often does not consider the capacity of ecosystems to regenerate the resources on which it depends and to absorb the waste it produces, creating harmful dynamics for human societies and the environment. In light of this, alternative models have emerged based on awareness of the planet's biophysical limits, such as the bioeconomy, degrowth, and the circular economy. In this lesson, we will explore the concept of circular economy. In its most basic form, the circular economy aims to overcome linear models based on the extraction, production, disposal paradigm by promoting strategies and practices such as material resource use reduction, reuse, and recycling, with the aim of relieving pressure on raw materials and limiting waste generation. The theoretical roots of the concept can be traced back to the concerns expressed in the late 1700s by the English economist and philosopher Thomas Malthus regarding the impact of population growth on food supply. These concerns began to take shape more systematically from the 1960s onwards, in parallel with the development of modern ecology and the growing awareness of environmental catastrophes caused by rapid technological change, particularly in the fields of chemical, energy, and mining. In 1966, Kenneth Boulding theorized the astronaut economy as the opposite of the cowboy economy. The Earth is not a boundless prairie from which the human being can draw all kinds of resources, but a spaceship with limited resources in which he must find his place in a closed ecological system. The idea that the Earth is a finite circular system gave rise to a series of subsequent theories and studies that would influence the development of the concept of sustainability. In 1972, the Club of Rome's The Limits to Growth report warned that if the prevailing trends of exponential population growth, industrialization, resource consumption and pollution remain unchanged, humanity would exceed the Earth's carrying capacity within a century. At the same time, urbanists and planners have begun to question the extent to which cities can be considered ecosystems that exchange energy and materials with the biosphere, in the form of nutrients, material, energies, gases emissions, and solid waste, and how they, precisely as places where human activities are concentrated, can actively contribute to reducing environmental impacts. Ecological principles suggest that cities and their infrastructural, environmental, and settlement systems should be rethought and reorganized according to a circular and regenerative metabolism, in which each output of one activity could become an input for another, in order to maximize resource use efficiency. For more than a decade, the concept of the circular economy has been incorporated into many European policies, such as those for waste, economic and regional development. The main objective is to boost the economy and job creation in times of economic, social and environmental crisis. However, the interpretation of the concept remains vague and predominantly oriented towards a paradigm of technological efficiency rather than radical system change, thus not really questioning the extractive and energy-intensive nature of contemporary technological applications. On the contrary, designing into a finite world means first and foremost being aware of the resource available in a given place. Soil, consumed by ever-increasing urbanization, by intensive agriculture. Raw materials for building, such as sand, earth from extractive hinterlands. Water, which is often too much or too little, responsible for floods or period of drought, and so on. Planning in a finite world also means rethinking urban metabolism from a territorial perspective, oriented towards balancing the relations, interests, and claims of a plurality of actors. This requires developing an overall vision based on the systematization of material resources, heritage and infrastructures, and immaterial resources, knowledge and know-how, belonging to specific but profoundly interconnected territories, such as mountain and valley context, deltaic and coastal environments. In short, When the concept of circular economy is extended to spatial planning and governance, the challenge emerges of overcoming the limits of a sectorial and compartmentalized planning culture, inherited from a modernist epistemology that sees man as separate from nature rather than an integral part of it. What is needed, therefore, is a general rethinking of urban planning culture, but also spaces for experimentation in innovative policy and design tools capable of supporting flexible and open processes based on the active and bottom-up involvement of a plurality of human and non-human actors. In conclusion, although the challenges related to circular cities are often presented as a technical and design effort aimed at resource efficiency, the transition towards an urban metabolism that is less impactful on the environment and less wasteful in terms of resource goes far beyond a simple ecological modernization. It is a complex challenge with profound implication, not only technological, but also cultural and political, requiring a renewed social organization and new ways of managing resources on a daily basis.